So let's think about what we did in that last video and maybe drew it in a little bit more of a visual way. So let's say this rectangle that I'm about to draw is the set of all the things, all of the things that can that I guess can happen. It's a set of all of the outcomes, right? And we know from the get-go, and we're still doing that same example where I have a bag of coins and one of them only has heads on it. Two sides are heads, the other ones are normal. So if this is the whole set of things, we know that there's a 1/10 chance that we pick the coin that only has heads. So let me see, out of this area, I don't know, this is half, that's a quarter. So a tenth is going to be about that much, roughly. So this area right here, that area right there, let me color it. Let me color it a color. So that area right there, that area, this is the chances that we got the two-sided coin. Two-sided coin. And this whole area, this is all a normal coin. Right? And then we said, oh, you know, what are the chances that we get 5 heads in a row? Well, if we got a normal coin, there was a 1 out of 32 chance that we get 5 heads in a row. So whatever this area is, 1 out of 32. So I'll do it a column, you know. It's roughly there. I can be a little messy. And I'm assuming that this column right here is 1/32 of this normal area. Right? So this is a situation of normal. I'll just write that as n, and that's upside down U means and in set theory, or it's a kind of an intersection, but it means and I got 5 out of 5 heads. 5 out of 5 heads. Right? And if we think about what is the area of this? Well, it's going to be the area, it's 1/32 of the normal area. Right? And the normal area is 9/10. Right? So this is equal to the normal area, which is 9/10, and then 1/32 of that times 1/32. Right? Or you could also, another way of viewing that area, you could say that, well, that area, that's the probability, I'll do it in the same color, that's the probability of me getting, I'll just write 5 out of 5. 5 out of 5 means 5 out of 5 heads. That's the probability of getting 5 out of 5 heads given that I picked a normal coin out. Right? Times the probability that I picked out a normal coin. Right? And so this is 1 out of 32, and this is 9 out of 10. And I'm assuming that the area of this entire magenta rectangle I drew, that's 1 or 100%, or however you want to view it. And so this is 1 out of 32 times 9 out of 10, so this is 9 out of 32. So if this whole thing, the area of this entire magenta rectangle is 1, then the area of this area, this that I just shaded in, this is 9 over 320ths. So 9 over 320. And another way of viewing this is also the probability, this area right here is also the probability that I got 5 out of 5 and that I picked the normal coin. Right? So that's also equal to. Both of those things are true in this area. In this area, if I have a point in that area, this might be a little abstract for you, if at any point, it is true that I got 5 out of 5 and I have picked a normal coin. So that's also going to be equal to, and I'm doing an arbitrary color change here, 9 out of 320. So we could say in general that the probability of me getting 5 out of 5 coins, given that I got a normal coin, times the probability that I got the normal coin, that is going to be equal that I get that 5 out of 5 happens and I got the normal. That equals probability of 5 out of 5 and I got the normal coin. Fair enough. So let's go to the other side of this. This kind of yellowish color here. There's a probability I got a two-sided coin. And then given that, what's the probability that you get 5 out of 5? Well, pretty much this entire area. It's also true that I get 5 out of 5. right? So the probability that I get, 5 out of 5 and two-sided, it's equal to the probability, and two-sided is equal to the probability of 5 out of 5 given the two-sided coin times the probability of the two-sided coin. So this is 1, right? If I got the two-sided coin, I'm definitely going to get 5 out of 5, and that's why this whole area is filled in. And then the probability of the two-sided coin we know already is 1 out of 10. So this area is 1 out of 10. 1 out of 10. And so what is the total area where I have 5 out of 5? Well, it's going to be this area over here, which I figured out, which was 9 3/20ths. 9 3/20ths of this entire rectangle. And then this whole area is also another area where I got 5 out of 5 because I picked the two-sided coin, and that's 1/10. And so in the last video, we would essentially, if we want to know the chances of getting 5 out of 5, it's this total rectangle. And I say this without showing you anything, so it'll be red. That, and I think you get the point, that is the 5 out of 5. So it's going to be this area plus this area, and that is why it was 9 out of 3/20ths plus 1 out of 10, and we had the answer last time. Fair enough. So let me pose a slightly more difficult problem. I don't know if I should have just erased that, but I did, so let's move forward. What is the probability that I picked the two-sided coin given that I got 5 out of 5 heads? And remember, this is different than the probability that I get 5 out of 5 heads given the two-sided coin. What's the difference? This says I picked the two-sided coin. Now what's the probability I got 5 out of 5? Well, that's equal to 1. We're guaranteed to get 1,000,000 heads in a row. But this says I put my hand in the bag. I didn't look at which coin I got. I just flipped it 5 times, and I know that I got 5 heads in a row. So now I say, well, what is the probability without, I guess, looking at the coin? What is the probability that this was the two-sided coin that I picked up? Well, we can go back to what we said before. Well, let me just say a little bit abstract. From the last, before I cleared this, we know that the probability of A given B, the probability of, well, actually, no, let me start on it. The probability of A and B happening, if you remember that thing that before I erased it, is the probability of A given that B happened times the probability that B happens, right? If both of these things have to happen, then we could say, well, definitely B has to happen, and then whatever is the probability of A happening given that B happened. And these could be exclusive events. I mean, this could be, if these are independent, this could be equal to the probability of A times the probability of B. But we don't know for sure that they're exclusive events. So, the probability of A given B could be the probability of A. It might not be dependent on B at all, but we don't know that. But anyway, let's ignore that. So the probability of A given B is that. But we also know that the probability of A given B is equal to, the probability. We also know the probability of A and B is also the same thing as the probability of B and A happening, right? The same thing. And so that's the probability of B given that A happened times the probability that A happened by the same logic. Well, we see that this is equal to this, so this has to be equal to that. So let's write that down. And we're going to do a lot of applications. I know this is a little abstract right now, but so that tells us the probability of A given B times the probability of B is equal to the probability of B given A times the probability of A. And then let's just divide both sides by A, and we get this. The probability of B given A is equal to this probability of A given B times the probability of B divided by the probability of A. And this is called Bayes' theorem or Bayes' law. And this is what we will now use to figure out the probability that we got the two-sided coin after seeing that we rolled or we flipped, we got 5 heads in a row. See you in the next video.